everyone, and welcome to Precalculus. Today we are in part B of section 4.3, right-angled trigonometry. On the first part of this section, we were introduced to what the trigonometric functions mean in terms of the right triangle. Now we're going to look at them as they relate to each other. So for example, tangent, in addition being defined as opposite over adjacent, which is how it is in its triangle. In terms of the other 5 trigonometric functions, tangent is the ratio of sine to cosine. And I'll just quick show you why that works. Because sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So if you flip and multiply, or some of you call it keep, change, I'm going to change the division to multiplication, and then flip, then I get hypotenuse canceling, and I get opposite over adjacent, which is what tangent is. So tangent is opposite over adjacent, but in terms of the other trig functions, it's sine over cosine. And I won't do that for everything I'm going to teach you today, but I wanted you to understand why it works. Cotangent is cosine over sine. If you're in honors, you're going to have to memorize these. If you are in college prep, you need to add these to your appendix. But it's still helpful to be so familiar with them. I assure you that if you don't have them pretty much memorized, this next section is going to be really challenging because you have to have them in your head to know when to use them. These next 3 are called Pythagorean identities. And again, I'm just going to prove the first one, which is sine is opposite over hypotenuse, squared in this case because we're squaring it. Cosine is adjacent over hypotenuse, squared. And to give this a common denominator, I'm going to make this one also hypotenuse squared and hypotenuse squared, which is 1. And then, of course, now that they all have the same denominator, I can clear the fractions, multiply through by hypotenuse squared. And I get opposite squared plus adjacent squared is equal to hypotenuse squared, which, of course, is true that if this is our theta, x, y, and hypotenuse, x squared plus adjacent squared is equal to hypotenuse squared. This is the Pythagorean theorem. And like I said, I'm not going to do it for all of them, but the other 2 are 1 plus tangent squared is secant squared, and 1 plus cotangent squared is equal to cosecant squared. So really, these 3 need to be memorized. So what today will do for you is really these problems are just to get you used to learning these rules. It's really just practice to get you to memorize them. So change each of the following to sine or cosine only. It doesn't matter which one. So tangent, look up on your top there, is sine over cosine times, just juxtaposition means multiplication, times cosine. And then the cosines cancel, and you get sine. This is a section that you can work really hard to do it on your own if you would like to. That's great. And then just come back and see if you did them right. Cotangent is cosine over sine times cosine. This time it didn't cancel. I get cosine squared over sine. So I have to make it either sine or cosine, but not a mix. So the only way to change a sine to a cosine is if it's squared. If it's squared, you can use this Pythagorean one. And I can replace cosine squared with 1 minus sine squared, and I'll show you why. Sine squared plus cosine squared. This is the main one that you want to memorize. But if I subtract sine squared from both sides, another way to think of this law is cosine squared theta is equal to 1 minus sine squared theta. So I can rewrite this as 1 minus sine squared theta over sine of theta. And now I did it. Now I made it into all sines. Some people like to write all the different forms on their appendix. You could do that. In this case, the third one would be that sine squared is equal to 1 minus cosine squared. You could put all three of these together so that you know all their different forms. Number 5, secant. So this rule is actually from the other day. Secant is 1 over cosine. So I'm gonna do this the long way the first time, and that is I'm gonna separate it into two separate fractions. So it's secant, and I'm gonna move the cosine into its own fraction. And then secant is the reciprocal of cosine. And now I have 1 over cosine times 1 over cosine is 1 over cosine squared. So this rule that secant of theta is equal to 1 over cosine of theta, you would have to go back to the very first page that we did on this. Actually just page 1 has what they call the reciprocal functions. So you can go back and make sure that those are on your appendix. You want everything on your appendix so it's nice and close. Little note that I skipped, but now I realize I need to go back and talk about it. So somebody was really clever. Somebody realized that oftentimes we're going to want to do sine times sine, which when we multiply two things together, we're usually writing it as something squared. But if you wrote it just as sine squared, that actually means that the theta is squared. We don't want the theta to be squared. We want the whole sine of theta to be squared. So you'd have to do this, which is great. But that's a lot of parentheses and a little annoying. So somebody smarter than me said, I have an idea. Let's put the square here, and then everybody will know that that means this. These two mean the same thing. If you ever see sine theta without the parentheses, that actually means sine of theta squared, which nobody bothers to write that. But it means that just the theta is being squared. So super important note. And that's why I wrote cosine squared theta. And we actually say it that way too, cosine squared theta. Okay, another reciprocal function for you. Secant. Actually, I'm going to go back up to this one and show you another way that you could have done it. Instead of doing it this long way, I just think to myself, a secant on the top is a cosine on the bottom. It's a reciprocal. Of course, you have to know what's left there, a 1. If there's nothing else up there, then you need to write a 1. So same thing here. This cosecant on the top, cosecant is the reciprocal of sine. So cosecant on the top is a sine on the bottom. There's another sine down there, so I'm going to put them both there. And now I have 1 over sine squared theta. Number 3, I realize we're going a little out of order because of the columns. Number 3, cotangent is cosine over sine. This is one where some people do like to separate it into two fractions. I hope you see how I'm doing that. I'm just pulling this one out, making it 1 over. If you multiplied it back, you'd be back to where you started. What is the advantage of this? Then when I change cotangent to cosine over sine, it's easier to deal with than if you changed it directly. People struggle if they do cosine over sine all over cosine. Then they've got that complex fraction. And a lot of people are bad at complex fractions. I will show you how to do it in case you're one of the people that's good at complex fractions. And if you did it this way, then you could say cosine over sine over cosine over 1, put the 1 there, and then flip and multiply, or keep change flip. The cosines cancel, and you get 1 over sine. But most people really struggle with the complex fraction. So it's easier for most people to separate it into two fractions. Now make cotangent cosine over sine. And then that gives you 1 over sine as your final answer. Okay, I am going to show you a third way. So that's two different ways to think about it. The third way, and this is the way that most people don't really understand why it works. But now that I've shown you two different ways to do it, because this is always going to work out like this, if you have cotangent, you can think of cotangent as the cosine staying on top and the sine just moving to the bottom with the cosine. A little bit trickier way to think of it. The sine from the cotangent being cosine over sine just moves to the bottom with the cosine, and then it cancels. If you understand the green way, that's great, but most people do not understand how that works. So you can stick with one of the first two ways I showed you. Number 4, tangent is sine over cosine times sine, which gives me sine squared over cosine. This is another situation where you need to use the Pythagorean identity. You are not allowed to leave the answer. The directions were to change them each to a sine or a cosine. So I go back to here. The only way to change a sine to a cosine is if it's squared. And you'll see that sine squared is equal to 1 minus cosine squared. So sine is squared is 1 minus cosine squared. So that's similar to the one that we did before. Number 7, here's another one of those where you're about to make a complex fraction. Cosine over sine over sine. Very tricky for most people. So what I find most kids are successful with is separating it. They're still leaving the sine on the bottom, but they're putting it into its own fraction. And then cotangent is cosine over sine times 1 over sine. That gives me cosine over sine squared, which is the reverse situation I had a minute ago. But the same rule applies. You can't change a sine to a cosine unless it's squared. If it's squared, you can change it by replacing sine with 1 minus cosine squared. It's just a rule. We call it an identity. And the last one. Again, this is going to become a complex fraction. So the safest way to do it is to break it down into 2. Tangent is sine over cosine. Hopefully you're doing this one a little bit faster than me and you're getting it. Times 1 over cosine is sine over cosine squared, which is sine over 1 minus sine squared. Like I said, the purpose of these right now is to become just to become more familiar with the identities. We won't actually be using them to solve things until a little bit later, and then we use them extensively in calculus. Hence the title of this course, Precalculus. All right, we're going to make it a step harder. Now the step harder is that it has to be a cosine. So before you could choose sine or cosine, and now it has to just be cosine. If you think you can do that on your own, I would love for you to stop the video and see if you can do it on your own. First one, sine of theta times cotangent is cosine over sine. The sines cancel, and I get just cosine. I hope you did that one on your own. Okay, so looking back at our Pythagorean identities, one of them is 1 plus cotangent squared theta is equal to cosecant squared theta. Let's rewrite that in a different format. You can rearrange this because you can see a cosecant squared and you can see a minus 1. So you can subtract 1 from both sides. And literally, cosecant squared theta minus 1 is, actually, I'm going to write it as this, meaning this whole thing is cotangent squared theta times sine squared theta. And now we're similar to what we were before. Now, because this is cotangent squared, cotangent is cosine over sine. If it's cotangent squared, then it's cosine squared over sine squared. So I'm going to replace this with cosine squared theta over sine squared theta times sine squared theta. These cancel, and I get cosine squared theta. Okay. This one is very challenging. We're going to start by getting a common denominator. So I'm going to multiply this top and bottom by cosine. Now I do need to add parentheses here, otherwise it's just the sine times the cosine. And on this one, I'm going to multiply by 1 plus sine. Do you see how now they have the exact same denominator? So this first one will be, if I do FOIL, first, outer, inner, last. And all of that is over cosine of theta times 1 plus sine of theta. And then this next one is easier, cosine squared theta. And then you'll also have cosine theta times 1 plus sine theta. So now I can write it as one giant fraction. I am going to simplify. My sine square, or my sine plus my sine is 2 sine. We haven't had to do that kind of a problem yet. So if you're multiplying trig functions, they become squared. If you're adding them, they increases the coefficient, just like with x's. Plus sine squared theta plus cosine squared theta. All over cosine of theta times 1 plus sine of theta. So they have a common denominator, so now I can make them all one numerator. Okay. This is why, even if you're in college prep, I cannot recommend highly enough that you memorize all the different trig identities, because otherwise you're not going to be able to get the next step. You have to have enough of it in your head to say, oh, look, sine squared plus cosine squared is equal to 1. Remember that Pythagorean identity? Sine squared plus cosine squared is equal to 1. So I can replace that with a 1. And now I get 2, because that 1 plus this one, plus 2 sine theta. This is a step that most people miss because they just don't have them memorized. There is one more step. I hope you see it. And that is if you factor out, I know factoring is never going to go away. There are some people that keep thinking next chapter, maybe I won't have to factor. It's never going to go away. Get good at factoring. So I factored out the 2, and I was left with 1 plus sine theta. And now my 1 plus sine theta is canceled. And my final answer is 2 over cosine of theta. Can you even believe that? We started off with this really hard addition problem with different denominators, and it ended up being equal to 2 cosine theta. And that's what's going to be so important, is that you're able to simplify problems so that you can then do harder math to them. You don't want to be doing harder math to ones like it looked like in the original. Okay, let's do proving identities. Okay. So originally, the goal was to get it in terms of sine or cosine. That was a warm-up. And then we made it a little harder. Now get it just in terms of cosine. Neither one of those are what we're going to do in the long run. In the long run, our goal is going to be to get it to be equal to a very specific thing. And that thing is going to keep changing. So they're saying this time, make it equal to 1. This time, make it a cosine. This time, make it a cosine squared. Okay, so every time what you're going to make it into will change. Here's what I want you to do. I want you to draw a vertical line separating the two sides. And the reason for that is because I don't want you to add to both sides, divide by both sides, subtract from both sides. You're not working on both sides. You're doing things to this side just like you did on all the other ones. So in the end, it looks like a 1. I'll show you. This first one, I'm going to leave the cosine. I'm going to change the secant to 1 over cosine. These cancel, and I get 1. Once it looks like the other side, I personally then bring this down and write 1 and either put a check or a smiley or something that shows me that I'm done. Some people just put the 1 there and then they're like, yeah, got it. You can't stop a step before that. Until this side looks just like this side, you have to keep going. So again, I'm going to draw a line, and when I get the left side to look like cosine, I can stop. So cotangent is cosine. Ooh, new Greek letter. This is the letter alpha. It looks like a little fish. I usually start at the top of the tail and make it like that. It's a fish. And it's pronounced alpha. It is a lowercase a in the Greek alphabet. So cotangent of alpha is cosine of alpha over sine of alpha times sine of alpha. And if you just stopped there, I wouldn't be happy with that. You need to write what the final answer is, cosine of alpha. Now you can bring this down, also cosine of alpha. You can tell I'm not a check mark person. I'm a smiley face person. All right, you can try this next one on your own. I'm going to make my line. And now I'm going to FOIL. You're going to use all the techniques you've used in your other math learning. So first, outer, inner, last. My signs cancel, and I get 1 minus sine squared theta. And then you may remember that 1 is the same as sine squared plus cosine squared, right? Sine squared, this was the first Pythagorean identity that you learned, plus cosine squared theta is equal to 1. So I'm literally going to replace the 1 with sine squared plus cosine squared. And then my sine squareds cancel, and I just get cosine squared. It's the same as this one, so I can bring it down, and I'm done. Okay, you do not always have to work on the left. You can work on the right if you want to. So I'll just show you another way to do this same problem. And that is, you could have said, well, this side is all sines, and this is a cosine. And she said a while ago that the only way to make a cosine into a sine was when it was squared. So I'm going to change this cosine to 1 minus sine squared. Remember that? Cosine squared is the same as 1 minus sine squared, which is just a rearrangement of this. Cosine squared is 1 minus sine squared. You can literally just use that. And then you could factor. You could say, oh, that's just like doing 1 minus x squared. So first times the first make the first. The last times the last make the last. And the inners and the outers cancel, so they must be opposites of each other. Look, it's the same. So this person chose to work on the other side. That's great. It's not that you have to work on the left side or the right side. You just have to pick a side. You just can't do things to both sides. No adding to both sides. No subtracting from both sides, dividing, etc., etc. Okay, here is another one. I'm going to always draw my line. The line is just to remind you not to do this. Without that line, sometimes kids do this. Minus sine squared theta. Minus sine squared theta. And they do it this way. That gives them 1 sine squared theta minus 1. Then maybe they multiply through by the negative. And then they're like, oh yeah, that's an identity, right? Cosine squared theta. Yeah, you can't do it this way. It's just not allowed. You can't add to both sides, subtract from both sides, none of that. So I make my line to remind me that I can't do it. So since this side has all signs on it, and this doesn't have all signs, it has sines and cosines mixed, I could use this rule. I could replace that cosine squared. It is negative, so don't forget that negative. But I could replace the cosine squared part with 1 minus sine squared. And then I distribute the negative. Sine squared theta minus 1. Distributing the negative gives me plus sine squared theta. And then sine squared plus sine squared is 2 sine squared minus 1. Now this is the same, so I rewrite it to show that I've finished. And I put a little smiley face because that's just my personality. I hope this is making sense. There are other ways to do number 4. Okay, I don't think I'm going to show you 2 different ways for every single problem. But you are more than welcome always to take a picture and say, is this a valid method? Because you already have the answer. This is the answer. I am literally checking your work. So if your work is wrong, and just because you get to 2 sine squared theta, I'm not going to look at that and say, oh, they did it right. I'm actually going to check line by line to make sure that it works. So the work is going to be everything in this section. The answer is literally worth no points. Usually the answer is worth 1 point, but I'm giving you the answer in advance. So like on this one, this is the answer. I need you to obtain that. This one looks terrible. It's not. I'm going to factor that top. So if you get something that's hard to factor, or you're just intimidated by the trig, take the trig out. If this had just been 9x squared minus 24x plus 16, could you factor that? Hopefully your first thought is 3x and 3x. You could try 9 and 1, but start with the easy ones. And same thing with 16. It could be 1 and 16, and it could be 2 and 8, but you got to start with 4 and 4. So I start with 4 and 4, and sure enough, this is 12x and 12x, which would make negative 24x if they were both negative. So literally this numerator is 3 sine of theta minus 4 times 3 sine of theta minus 4. If you can, you should stop this video and see if you can factor that denominator. Because the inners and outers canceled, it must be 3 sine theta plus 4 times 3 sine theta minus 4, just like x squared minus y squared factors to x plus y, x minus y, when there's no middle term. So now I can cancel this, and then I write the final step. 3 sine theta minus 4 over 3 sine theta plus 4. And on this side, this one's a little bit annoying to rewrite the whole thing at the last step. Don't be lazy on me. All right, I'm not going to go through the whole thing, but just real briefly, another way to have done it, to work on the right-hand side, you could have done this by multiplying the top and the bottom by 3 sine theta plus 4. That would have given you what's on the left. So somebody might have thought to do that instead, and that's also a valid method. Okay, last one. So you'll notice I have little notes in parentheses here. Those are giving you some different strategies you might want to add to your appendix. One strategy is separating a fraction into 2 separate fractions. I know what we're used to doing is seeing 2 separate fractions and putting them into 1 fraction. So getting a common denominator, 2/4 plus 3/4, and making that 5/4. What we're not used to doing is actually separating it back into 2 separate fractions. Tangent of theta over tangent of theta plus cotangent of theta over tangent of theta. So Think about that. Now that they have a common denominator, I could put them back up to that first step. But very unusual. We're separating the fraction into two separate fractions. Make my line to make sure I don't accidentally cross it. So this becomes 1. And now we're going to do something we haven't done on this problem, on this section yet. And that is another reciprocal function, but one we haven't used. Tangent is 1 over cotangent. 1 over tangent is cotangent. They're reciprocals of each other, which means a tangent on the bottom can be moved to the top and be made into a cotangent. So I'm going to take this tangent and it's reciprocal. I'm going to move it to the top and make it a cotangent. Let me just make myself a little bit of room here by getting rid of all your homework. And then this becomes 1 plus cotangent squared. And that is an identity. 1 plus cotangent squared. It is the third Pythagorean identity, is cosecant squared theta. So now I can write the other side, my smiley face. I'm good to go. So remember, this is one idea that you can use when you're trying to do your homework, separating the fraction into two separate fractions. Let's see, another idea was looking at the Pythagorean identities, getting a common denominator. Okay, those are some things that you want to keep in mind as you're trying to do these problems. And then here was the steps. I guess I only talked about step 1, but use a vertical line to separate. Use your known algebraic and trigonometric identities to replace something with an equivalent expression, like secant is 1 over cosine, and just keep repeating that process until an expression is obtained that is the same as on the other side of the line. Okay, that is it for today. I hope you have a great day.